All right, lesson 3 in our volume um, unit is population. We're talking about density, and we're going to focus on population density. Okay, so population density. I'm going to abbreviate population density as PD. Okay, PD stands for population density. So population density is the number of people over land area. Okay, number of people over land area. So each one of these questions we're going to be asked to either to calculate population density or use the population density to solve problems, and we're going to be comparing between two things. Okay, so for number one, it says a 4,800 square foot school was opened up in a small town. At the time the school was opening, the population density of the school was only 0.046. Over the years, the town has seen an increase in residents, and now it's time to decide if there will be a new school built or not. The principal determined that if the population density of the school reached a level greater than zero point 0.1, then an additional school would be needed to be built. How many students were enrolled when the school first opened? Okay, that's our first question. How many students were enrolled when the school first opened? If 176 new students have enrolled since the school was first opened, what can be said about the new building? So, in order for us to decide if the new building needs to be if a new building needs to be built, we need to find out first what the population of the school was um when it was first built, and then add our new students. Okay, so in order for us to do that, we have our formula. Population density equals the number of people divided by the land area. Okay, so our population density that we know was underlined here, 0.046. So we're going to say 0.046 equals X, because we don't know the number of people because we're asked to find that. X over the population of the town. What is the population of the town? Okay, the population is 4,800. So once we solve this, if you want to, y'all know how we do. You can put this in Desmos. Y equals this, y equals this, and your X value should be what? 221 students. Okay, so our original population was 221 students. Now that we know the original population of 221 students, we can find the population density of the school now. Okay, so we can find the population density of the school now. So we said since the school was built, there's 176 new students. So if I take my original amount of students, which we just found, which was 221, and I'm going to add 176 to that, that's going to give me a total of 397. Okay, 397 students. That's my new population. That's my number of people over the land area. The land area, again, is the population of the town. So the population of the town, again, was 4,800. So if we calculate this, we do 397 divided by 4,800, and that answer is going to be 0.083. Okay, so that's the population density, 0.083. Now, the principal said that if the population density was greater than zero point 0.1, then they needed an additional school. So the question asks us, do they need a new school? No, we do not need a new school because zero point 0.1 is what we need, but our answer was 0.083, and we're not rounding because we need the exact density. Okay, so we do not need a new school. All right, so let's go to question number 2. Question number 2 is asking, there is an island located off the coast of South America that is approximately 4,500 square feet. So we're going to underline 4,500 square feet, okay? Because that's going to tell us um, how big the land is, and contains 608,000 inhabitants. That means that's 608,000 people, okay? According to the previous year's hospital records, 11,275 children were born, but 9,850 inhabitants died. So, with the population, we had 608,000 people. They had 11,275 people to be born in that next year, and 9,850, I didn't say that right, died. Okay, so the local government believes that they can support a population that is as dense as 135 people per square mile. Given last year's medical records, can the government support the new population? So we're trying to figure out if they can support the new population um given the death and the births that they had in the city. I'm sorry, on the island. So first, we need to figure out again, population density is equal to what? Number of people over land area. Okay. So now we need to figure out the number of people. How many actual people are on the island so we can figure out our population density. So we began with 608,000 people, and then we had 11,275 people born. So we're going to add that. And then we're going to subtract how many? 9,850. Okay, we're going to subtract 9,850 because that's how many people died. And so now, what is the total population that we have? 609,425. Okay, that's gonna be our new population, the number of people. So the population density equals 609,425 over, correct, it should be over the land area, which is 4,500. Okay, and when we divide that, our population density equals 135.43. Now, it says, can the government support a population? It says the government can support, sorry, a population that is as dense as 135 people per square mile. Now, according to this, can the government support this population? No, they cannot, because they have that 0.43. That can be somebody pregnant or anything. So that 0.43 makes that greater than that 135. So they cannot support the new population. Okay. Number three, it says a skating rink in the shape of a circle has a diameter of 160 feet. The owner of the rink realized that there were injuries on the rink floor when the population density increased. On any given Saturday, he found that at 2 p.m. the population density was at 0.096. At 6 p.m. there were 265 people out in the rink. Was it more dangerous to be on the rink at 2 p.m. or 6 p.m.? And how do you know? And he wants us to use 3.14 for pi. So first, we need to know what our land area is. Okay, so in order to find the land area, we need to figure out the area of this rink. This is a circle. So what is the formula for a circle? Pi r squared is the formula of a circle. So we're going to do 3.14 times our radius. We have a diameter, so what is the radius? Correct. The radius is 80. So we're going to do 80 squared. So 3.14 times 80 squared gives us an area of 200.96. Okay, that's the land area that we're looking at. That's the area of the skating rink. So 200.96. So, in order for us to find the population density, we know that the population density at, let's start at the first one, which was at 6 p.m. So, the population density at 6 was 265 people because it says 265 people were on the rink. So, population density at 6 p.m. was 265 over our area, which is 200.96. Y'all, not 200.96, 2,000, 20,096. Okay, 20,096. Okay, 20,096. So we're going to do 265 divided by 20,096. Okay, and when we do that, that gives us a population density of 0.013. Okay, so that's the population density. And then it already told us what the population density at 2 p.m. was. So the population density at 2 p.m. was 0.0096. So it's asking us, was it more dangerous to be on the rink at 2 p.m. or at 6 p.m.? Which one is more dangerous? 6 p.m. is correct. It's more dangerous to be on the rink at 6 p.m. because the population density is greater. Okay? All right. So that's our lesson on population density. Make sure that you submit all of the assigned work.